Okay, so we've been learning how to solve one-step equations, inequalities, two-step inequalities, multi-step inequalities, and now we're going to talk about something that's called compound inequalities. And basically a compound inequality means that you've taken two inequalities and you've combined them into one sentence, and you've connected them with the connecting word of either and or the connecting word or. Okay. In a compound inequality, if we make a statement like that, we're saying in something like this right here that x has to be less than 2 and x has to be greater than or equal to -1. Okay. So x is less than 2. If we graphed it, we'd have an open circle on 2 and an arrow going to the left. If we graphed x is greater than or equal to -1, we'd have a closed circle on -1 and an arrow going to the right. And because the connecting word is and, what you're looking for is that area where they overlap at, which would just be between -1 and +2, but not including 2. That's what the open circle is. Including -1 with the closed circle, not including 2 with the open circle, and everything in between. Think about it. X has to be less than 2 and greater than or equal to -1. If you are given a problem like example 2, this is essentially a compound inequality with the connecting word of and. It says -1 is less than x plus 2, which is less than 3. You can solve this. I'm going to rewrite this over here so I have a little room. This one's different than what we've seen. If I wanted to solve this, I still want to get x by itself. But it's not on one side or the other. See how it's in the middle? Well, if I wanted to get x by itself in the middle here, I would take away the 2, and that would leave x by itself. Well, normally what you do to one side, you got to do to the other side. But there's two sides. So which side do I do it to? I do it to both. So in these types of problems, where your variable's kind of in the middle between the inequality signs, whatever you do in the middle, you go outside and do to both the outsides. So now we get -3 over here, and we get +1 over here. So this sentence says that -3 is less than x, and x is less than 1. So if you think about it this way, x is less than 1, I'm going to cover up part of it. X is less than 1 means numbers that are smaller than 1. And if I cover up this side, then I get -3 is less than x, or if I read that backward, x is greater than -3. So if you follow me here, what this sentence is saying is that x is somewhere between 1 and -3. So if you look at the graph of that, this one right here, x is between 1 and -3. Just like that. Okay. So some of your problems will be like this. B is greater than -1. So I have an open circle in -1, and I know greater than means my arrow is going to go this way. But before I draw that arrow, look at this. B is less than or equal to 3. So I'm going to have a closed circle on 3. And less than means goes this way. So if I'm looking for numbers that are greater than -1 and smaller than 3, I'm looking for all of those numbers in between. So that would be my solutions. Okay. In number 2, what this is stating is the letter Q, whatever that number is between 2 and -5. And because of the equal bars, I'm going to have closed circles, -5 and at +2. Q is greater than -5 goes this way. Q is less than 2 goes this way. So that statement, you'll see that time and again. You need to be able to read that. That just means that Q is between these two numbers. Between 2 and -5. Okay. If we have to solve one, let's look at one of these like number 7. If I want to get W by itself, it's in the middle now. So if I want to get W by itself, I would simply take away 3 here. Now instead of what I do to one side I do to the other, it's what I do to the middle, I do to the outsides. So 4 minus 3 is 1. This cancels and leaves me with W. And 5 minus 3 is 2. So what this is saying is W is somewhere between 1 and 2. So you're going to put circles at 1 and 2, but you got to remember, is it open or closed circle? So I got an open circle at 1, I got a closed circle at 2, and W is in between those. So we just want those numbers right there. Okay, let's look at the harder one for this one, number 12. I'm going to rewrite this so I have room. It says D minus 3 is less than 6D plus 12, which is less than 2D plus 32. For this problem, I think it would be easier, it would be easier to do this, to split this up into 2 different inequalities and say D minus 3 is less than 6D plus 12. There's one of them. And then your other one would be this one. 6D plus 12 is less than 2D plus 32. And now I can solve those. Here, take away the D from both sides, and you're left with negative 3 is less than 5D plus 12. Take away 12. Negative 15 is less than 5D. I would divide by 5 and get D. Negative 15 is less than D. So negative 15, oh, sorry, I didn't divide by 5. Negative 15 divided by 5 is negative 3. So negative 3 is less than D. So I'm going to have an open circle here. For this one, I'll come back and draw the arrow in a second. For this one, I'm going to take away 2D from both sides. And I'm left with 4D plus 12 is less than 32. Take away 12 from both sides, and you're left with 4D is less than 20. Divide both sides by 4, and you get D is less than 5. So I'm going to have an open circle at 5 because there's no equal bar. So here's my 2 solutions. D is greater than negative 3, so it's going this way. Remember, this one's backwards. And D is less than 5. So we want everything, in between. Okay. Okay, sometimes the connecting word is not and, it's or. But we work them the same way. So if you look at number 1, B is greater than 2, or B is less than or equal to negative 3. Closed circle and the arrow going that way. With the ands, they normally come in toward each other, the lines do. But with the ors, they normally go away from each other like this one. So if you notice the ands, this is the ands, they come into each other. The ors go away from each other. So for this one, 3 is greater than or equal to Q. Read backwards is Q is less than or equal to 3. So this arrow is going to go this way. Q is less than or equal to 1. So we've got a circle here. So the arrows for this one, now I said normally, but not always, these arrows are going the same way. So since the connecting word is or, I only need where one of them is true. And from here on, at least one of them, and sometimes both of them are true. Okay. Look at the 3. Y is less than or equal to negative 4. Or y is greater than 0. Easy peasy. Let's look at number 8. So this first one, here's your connecting word here, or. So this first one says negative 3p plus 1 is less than or equal to negative 11. So if I take away 1, I'm left with negative 3p is less than or equal to negative 12. If I divide by negative 3, I get p over here, and I have 4 over here. But that rule always applies. I divided both sides by a negative, so I need to flip the sign. And this turns into p is greater than or equal to 4, which means I'm going to be here greater than or equal to. Now the other part was p is less than 2. I get students asking, since the connecting word is or, does that mean I just have to pick one or the other one? I have to choose one to graph. I don't have to do both. That is not true. You have to do both. Okay. So with the ors, if you see these two problems, number 10, you solve this and graph it. Solve this part and graph it. You have to do both. 3a plus 2 is greater than or equal to 5. Solve that, graph it. Then 7 plus 3a is less than or equal to 2a. I'm sorry, less than 2a plus 6. Solve that and graph it. Okay. These are called compound inequalities because they are connected with a qualifying word of either and or.